Okay, let's talk about how market shocks affect our expenditures and purchases of various goods. In this story, we're going to compare that composite good Dukes, which is $1 worth of anything not on the x-axis, to our pizza consumption choices. And so first we're on U-naught, BC naught, consuming P-naught units of pizza. This could represent a certain number of slices per day or per week. There's this market shock, pizza goes on sale, so the price of pizza declines. And the question is, how does this change our budget constraint? If you're struggling with how to move budget constraints with market shocks, make sure you check out the video on how budget constraints shift or rotate. Otherwise, what we can do is just analyze it like this. If you spend all your money on Dukes, the price of pizza changing doesn't change how many Dukes you get to have. But if you spend all your money on pizza, in its extreme, you could have more pizza if pizza was on sale. And so we're going to go ahead and rotate that budget constraint out and call that BC1. So our very next step is to analyze the final bundle. So in our previous analysis, we kind of said, because indifference curves don't cross, it's anywhere between the intersection of U-naught and BC1, but we can do so much better now that we've introduced substitution and income effects. So what is the substitution effect? The substitution effect is just the law of demand in action. It behaves exactly like you've been taught the law of demand behaves, meaning when the price of pizza goes down, you would expect people to consume more. And so the quantity of pizza consumption goes up. And that means you would expect that for the substitution effect, our point C would end up to the right, expanding the consumption of pizza. So how do you figure that out? I highly recommend your trusty see-through ruler. And what you're going to do is you're going to line it up with BC1. Okay, because that is the budget constraint that represents the new prices. The substitution effect is how we would respond to the change in price if I was forced to remain on U-naught but face the new high price. So the new high price is represented by the shape of BC1. You always go to BC1 no matter what the market shock is. And then you're going to go ahead, in this case, shift it back until you get to a tangency point with U-naught. And for me, it looks like it happens right about here. And so I'm going to draw a compensated budget constraint at point C, and this is the compensated budget constraint. It's parallel with BC1. It doesn't have anything to do with our original consumption amount. If I were to be able to zoom in on this, you would see that this BC sub C actually cannot go through point A. And so if I was going to exaggerate that difference, I might even show. It very definitely is going behind point A. Point C is always going to be on U-naught, and from P-naught to PC as a result of the substitution effect. And we have that arrow that starts at P-naught and ends at PC, our consumption amount, not our endpoints, just to be clear. And so now I have to analyze the income effect and the fact that when prices change, we are always either richer or poorer as a result. And so how we analyze that is our second bullet point here. And we need to ask ourselves 3 questions. No matter what industry we're in, we always ask the same questions. Did the market shock result in me being richer or poorer? In this case, since prices declined, I'm richer. Is this a normal or inferior good? Now, if I tell you that the angle curve is upward sloping, meaning the relationship between income and consumption is positive, then you know it's a normal good. If I tell you the relationship between income and consumption is negative, you know it's an inferior good. Let's go ahead and say the relationship is positive, so we're working with a normal good in this analysis. And then finally, from point C, I ignore point A. Point A doesn't exist anymore. Do I consume more or less normal goods when I'm richer? And the answer, of course, is that I consume more. So how much more depends on the size of the income effect. I know I have to continue to walk in this direction, so I know that I have to be somewhere over here on BC1. BC naught doesn't exist, so don't put point B anywhere other than somewhere on BC1. You need to reflect the positive influence of the income effect. And so in my case, my options are like probably somewhere between here and here because indifference curves don't cross. So these are about my options. If I put it down here, I'd have to draw a really funky indifference curve that wouldn't be the same shape as U naught. I'm gonna go ahead and pick one that's right about here. I'm gonna call that point B. And our final bundle that I actually observe the consumer choosing is P1. And so from PC to P1 is a result of the income effect. And I'm going to draw finally, now that I'm all done with the analysis, an indifference curve that's the same shape as U naught, convex to the origin. And so I observe in the marketplace P naught and I observe in the marketplace P1. This is something that's invisible to us and can only be found in the analysis with the data. Now this consumer is better off, and the reason why they're better off is they're on a higher indifference curve. So if you recall, there were some videos that talked about how indifference curves fill a plane, and the higher you are, the higher level of satisfaction. So because U1 is greater than U naught, I am indeed happier, more satisfied with, at the end of the day, more pizza when the price of pizza has gone down. Let's do the same analysis, only let's look at what happens when we're looking at an inferior good in the next video.